Hello. We're going to go over the quiz that you wrote yesterday. Reviewing this quiz is probably the best thing you can do in preparation for your test tomorrow. So try to watch this whole video. Make sure you understand each one of these questions. It covers basically everything that we've done. Start with question 1. Which number system contains all of the others? This means what number system is the biggest, essentially, right? Contains all the others, means everything else is inside of it. So the biggest number system is the real number system. If you remember, we did a little picture where we had all these circles of number systems in a big box. I would go find that in your textbook and review that if you're not sure about the number systems and which systems are which. Number 2. Which description about the number 5,832 is correct? Okay, question number 1 says that it's a perfect cube number. If something's a perfect cube, that means you should be able to cube root it. Okay, so if you throw in your calculator the cube root of that number 5,832, you get a whole number. You get 18. That means it is a perfect cube, so that is true. Now, if you keep going, though, it says it's also a perfect square number. And you should probably test that because the future answers talk about it is a perfect cube and a perfect square. So if something's a perfect square, that means you can square root it. So if you try that in your calculator, you're going to square root 5,832. It equals 76.36 and then a bunch more numbers. That means it is not a perfect square number. So the answer is A. It's a perfect cube number. It's not a perfect square. Perfect. Number 3, determine the greatest common factor of 56 and 88. Greatest means biggest. Common means for both. And factor means can divide into. So you're looking for the biggest number that can divide into both of 56 and 88. Now the proper way to do this is by using a tree, right? So remember we would do our little GCF trees or whatever. But since it's multiple choice, we could actually just test these answers and see which is the biggest one of these that divides into those two numbers. So for sure 616 doesn't work. If I try 28, 28 divides into 56. And 20 does not divide into 88, so it's not 28 either. You try 8. 8 divides into 56. And 88 divides by 8. So 8 is the greatest common factor. That's the biggest number that divides into both. Awesome. 4. Which is the prime factorization of 630? Prime factorization is do the trees. So you take a number and you divide it into a prime number. So that's a number that can't be divided. And its result. So for instance, 630 could divide by 2 and 315. And then you do the same thing with 315. You divide it by a prime number. 315 divides by 3. And you get 105. Notice that I'm circling the prime number because that can't divide, so I don't go any further with that side of the tree. 105 can divide by 3. It gives me 35. 35 can divide by 5. The result is 7. The numbers that I've circled is called your prime factorization. So we have 2 times 3 times 3 times 5 times 7. If we look at our answer, that's it right here, D. They just didn't do 3 times 3, they wrote 3 squared. Awesome. Number 5, express the square root of 98 as a mixed radical. Okay. This is where we're going to take a radical. So radicals look like this, right? And we're going to give it a coefficient, meaning that we need something out front. The way we do that is by finding a number that divides into 98, and that number has to be a perfect square. So for instance, if I had square root 98, 98 can divide into 49 and 2. Right? 49 is a perfect square number that divides into 98. The reason I would do that and I would take that and I would break it up into two radicals, is this number is a perfect square, meaning if you calculate it, it equals a whole number. That becomes your coefficient. The square root of 2 stays the square root of 2, and this simplifies to be 7 root 2. Number 6. Which of the following can be simplified to a to the power 6? All right, looking at the first one. That's a to the 4 plus a to the 2. We have no exponent rules that can combine those. There's nothing you can do with that. They're not like terms. There's no exponent law for adding powers. Number 2, a to the 8 minus a to the 2. We have no exponent law for subtracting powers. That's not a thing. Number 3, a to the 3 times a squared. Okay, well, we can simplify that with our exponent rules. Our rule is if you're multiplying powers, you add the exponents. So if you add those exponents, you get a you get a to the power of 5, which is not a to the power of 6, so it's not number 3. Look at number 4. We have a to the 12 divided by a squared. We want to subtract the exponents on that one because it's dividing. So dividing means subtract the exponents. 12 minus 2 would be a to the power of 10. Okay, so it's none of the above. None of those turn into a to the power 6. Number 7, express as an entire radical. That means we don't want the coefficient. So we need to get rid of this coefficient somehow. To get rid of this coefficient, you take it, you move it underneath by the radicand, and you multiply it to the radicand. Now remember in math, anytime that we do something, right, we have to balance it out. So when you move a number under a root sign, you have to balance out the fact that you're now rooting that number. The way you balance it out is by giving it an exponent that's the same value as the index. So this is a cube root. That means I'm going to cube that number I just put under there. So it looks like this. Cube root 2 times 2 cubed. If you calculate your new radicand value, that will give you the cube root 16. The answer is C. Number 8. Expressed as a mixed radical. All right. Same thing as before. We're going to turn this into has a coefficient. Okay, so to get a coefficient, we need to find a perfect cube number that divides into this. Remember, I'm finding these numbers by looking at something called my cube chart. Right, so these are numbers to the power of 3. I'm trying to find a perfect cube that divides into 80. If you look, the only one that works is going to be 8. So that means I can rewrite this as cube root 8 times cube root 10. The cube root of 8 is 2. That becomes your coefficient. The cube root of 10 stays cube root of 10. It's 2 cube root 10. Number 9. Simplify. Okay, we're going to do our exponent rules. You have to do the exponent rules in the right order. Okay, so we have to deal with those brackets first. So this squared comes in and it multiplies to the exponents of those two things. So it's not 5 times 2, it's 5 to the power of 2. And then this is a to the power of 3 times 2, which is 6. The other part of the question just kind of stays there for now. So I got that now. I have 5 squared a6 times 2a4. Our coefficients are going to multiply together. So 5 squared times 2, you can put that in your calculator, is 50. And then our powers will go together. Because it's multiplying, I will add the exponents. So it becomes a to the power of 10. 50 to the power of 10. Number 10. Simplify. Okay, so if I got that thing, we're multiplying, means we're going to add the exponents together. A's will go with A's, right? So I have a to the negative 2, a to the power 3. If you add those exponents together, it's a to the power 1. And then I have a to the power of 6, b to the power 6, b to the power negative 8. If you do 6 plus negative 8, you'll get negative 2. You'll notice that that does not appear anywhere in your answers. That's because we don't allow negative exponents. When you have a negative exponent, you take the entire power and you put it on the bottom of your fraction, like that. The answer is A. A divided by B squared. So negative exponents go to the bottom of a fraction and it changes it to a positive exponent. All right, number 11. We're dividing. That means divide, right? So it means we're going to subtract exponents. We're going to start with our coefficients, though. When you have two coefficients, you find a number that can divide into both of them. They both can divide by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. Then you're going to do your A's. So a to the 3, a to the 1. You subtract the exponents, becomes a to the 2. Then you're going to do your B's. B to the negative 7 minus 6 will become b to the negative 13. Negative 7 minus 6 is negative 13. Again, you're going to see that answer is not there anywhere because you're not allowed a negative exponent. So you need to move that power to the other side. All right, b to the negative 13 goes to the bottom. It becomes b to the positive 13 like that. So your answer is 4a squared 5b to the 13a. Oh, sorry, it's not a. D. There we go. Okay, number 12. Simplify. We have an exponent on the outside. That thing needs to come in. Same with this one on the bottom. Needs to come in. When it comes in, it multiplies to the other exponents. So 3 times negative 1 becomes negative 3. Negative 3 times negative 1 becomes positive 3. The denominator, negative 2 times 4 becomes negative 8. b to the 1 times 4 becomes b to the 4. From there, we can use our subtraction law because we're dividing. A's will go together. Negative 3 minus negative 8 becomes positive 5. So negative 3 minus negative 8 on those exponents. We get the B's. 3 minus 4 is negative 1. So I have a to the 5, b to the negative 1. Those b values, because they're negative exponents, have to go to the bottom. So the answer is a to the 5, b to the 1. Number 13. Simplify. Before I bring this in, before I do all that, I'm going to look inside those brackets and realize I can simplify a whole bunch of that stuff. So I'm going to go ahead and do that first. Coefficients with coefficients. Both those numbers can divide by 2. Negative 54 does divide by 2. It just becomes negative 27. Then I'm going to look at my x values. X to the 6, x to the negative 3. Subtract those exponents. 6 minus negative 3 is 9. And then I'm going to look at my y's. I have y to the 1, y to the 4. That becomes y to the negative 3. And then that exponent on the outside is still there. Perfect. Now we'll bring this in. And it's going to multiply to all those exponents. So I have negative 27 to the power of 4 over 3. I have x. If you do 9 times 4 over 3, you get 12. And I have y. If you do negative 3 times 4 over 3, you get negative 4. Perfect. To finish this question off, you need to get rid of that negative exponent. You also need to calculate this coefficient. Put that in your calculator. And you should get 81 when you calculate that, x squared. X to the 12. And then the y to the negative 4 goes to the bottom and becomes positive 4. So the answer is D, 81x to the power 12 divided by y to the power 4. Awesome. Number 14. Write that as a power. Okay, so we're taking radicals and turning them into powers. When you take a radical and turn it into a power, you're going to turn it into a fraction exponent, right? The way it becomes a fraction is you take whatever your index is, in this case it's a 2, and it becomes the denominator of your exponent. So I end up with 3 over 4, 9 over 2 in the exponent. The answer is B. Evaluate. So all you had to do is put this in your calculator. If you put it in your calculator, I believe you are going to get B, 625 over 16. I'm going to try it just to make sure. Yeah, I get. Yeah, you do get that. So if you put in your calculator, it's 39.0625. This is the same decimal, 39.0625. So the answer is B. If you look at 16, which expression is equivalent to? This is a hard one. It's hard for two reasons. First reason, there's a negative exponent. So let's get rid of that negative exponent. To get rid of a negative exponent, the entire power, which is all this, goes to the bottom of a fraction. So I now have this. And it's now a positive exponent. Perfect. Next thing I got to do, I have to get rid of that radical, right? Or that fraction exponent right here. Because if you look at all your answers, they're all radicals. To turn this into a radical, the bottom number becomes the index. So the bottom number of that fraction is a 3, so the index becomes a 3. Everything else is going to stay the same. So it looks like that now. Technically, there is still like a 1, like that's to the power of 1. You don't have to write 2 to the power of 1 because it doesn't make a difference. It's just 2 times 1 is 2. So you move the power to the bottom and then you change it into a radical. And you get that answer, which if we look here quick, it's A. This guy, if you put in your calculator, you should get 25 over 36. Again, just put in your calculator, find the decimal, and then match the decimal. This guy. This expressed as a power, so we want to get rid of it. This is the same trick. So you're going to take this, and it's going to become the fraction on your exponent. So if there is no exponent, it would be 1 divided by, and then it goes there. So I now have this, x to the 1 over 3 squared. That then multiplies, so it becomes x to the power of 2 over 3. B is the answer. The index became the bottom of the fraction in the exponent. Number 19. Which of these equations is true? You go ahead and you calculate them. There's a plus minus there, which we haven't really seen before. So like if you see something you haven't seen before, like this, just assume that thing's going to be false. Like, I've never seen that before, so it can't be true, right? Looking at 3 is false. You can't square root a negative, right? That's not allowed. The only one that's true is I. So D, I is true. This one, you just have to change all these to decimals and then rate them in increasing order, right? Because decimals are easy. So this is 11.3. If you calculate this one, it's 11.8. 2 squared of 33, that's 5.7. And you do this last one, 10.3. So you want to do it in increasing order. The answer would be C. #21. Which of the following examples does not represent a rational number? So a rational number is a fraction or a decimal that stops, or a decimal that repeats forever. So which one is not a rational? A repeating decimal? Nope. That is exactly what a rational is. A terminating decimal? Nope, that's what a rational is. A number that can be expressed in the form a over b. So that's saying a fraction. Fractions are rational numbers. A number that cannot be expressed in the form. Yeah, that's not irrational. Yeah. If it can't be written as a fraction, it's not rational. 22. Two students were simplifying expressions involving powers. Their steps are shown below. You have Monique and Steve. We have to decide who's right. So to figure out who's right, you're going to start with one of them and just try to figure out what they've done. So Monique, from here to here, if I'm looking, the -2 is still there, but the inside has changed. So what's changed on that inside? Oh, sorry. So you can see that the 2's, those exponents have stayed the same. If you look at the top, that's actually stayed the same too. So the only thing that's changed here is the denominator in purple. Now, you don't have to check to see if they did what you would do. You have to check to see if what they did is mathematically correct. So did they change those purple things properly? They went 4 minus 3 squared became 1 squared. So they did 4 minus 3 and then left the squared alone, which breaks our BEDMAS rules, right? You have to do the exponent first if you were to subtract those things. So you can't do that. So that means Monique is wrong. Okay, looking at Stephen. First thing I noticed about Stephen, this is gone. Okay, so let's see if he did it properly. The way to get rid of that properly would be to multiply it in to all the exponents. Okay, so let's see if he did that properly. -2 is correct. 2 times -2 is -4, that's correct. -4 times -2 is 8, that's correct. And 3 times -2 is -6, that is correct. So far, Stephen is doing good. Then, from step 2 to step 3, I see that the x's on the bottom are now gone. It looks like there's an x on the top. And this 3, -2 is gone, but there's a 9 here somehow. So let's see if he did these things properly. So to get rid of this 3 to the -2, first, it's a negative exponent. So that means it has to go to the bottom to become 3 squared. And 3 squared is 9, so that's good. Next, x to the -4, x to the -6 became x squared. Well, we'd have to use our subtraction rule, right? So -4 minus -6 is 2, so that's also correct. That means Stephen is correct, Monique is incorrect. The answer is C. All right, numeric response. Use the following information to answer the following questions. Write the value of A in the first box, B in the second box, C third box, D fourth box. Okay, look at this. You have to decide what value of A goes there to make this true. Well, we know that when you have an exponent with an exponent, that you multiply. So 4 times something became 8. The number that must have been there is 2, because 4 times 2 becomes 8. So the first box is 2. The same rule applies here to B. that has to multiply in. Something times 2 becomes 8. That would be 4. For C, I'm multiplying bases, which means I add the exponents. So C plus 3 became 9. So something plus 3 became 9. That would be 6 plus 3 became 9. And the last one, I have division. Division means I subtract the exponents. So something minus 2 became 3. That'd be 5 minus 2 became 3. So the answer was 2, 4, 6, 5. Number 2, express in simplest form. Okay, simplest form means that you have the smallest possible radicand. So 180 means it can get smaller. To simplify this, you have to find a perfect square number that divides into 180. 36 divides into 180. So I would rewrite that as instead of root 180, I would go root 36 times root 5. Because 36 times 5 is 180. Perfect. The 5 is still out front. The root 36 you can calculate to be 6. And the root 5 stays there. 5 times 6. Right? If you have two coefficients, you multiply them together to become 30 root 5. They said that your answer would look like this. A number, square root, a number. That's exactly what I have. I have a number, square root, a number. Then they want to know what is the first number minus the second one number. What is A minus B? What is 30 minus 5? It's 25. So the answer for the box was 25. Last one. Jermaine wants to paint a cube with a volume of 2,744. Each can of paint covers 82 meters squared. How many cans of paint must she purchase if she wants to paint the surface area of the cube? Okay. How are we going to get from volume to surface area? So if you had a cube, I'll do a terrible attempt at drawing a cube. There's my cube. Yikes. And they're telling you that the volume of it is 2,744. That means that the inside, if you filled it up, it would be 2,744. You need to go from volume to surface area. Surface area equals length times the width, which is the same thing, times 6. Because there's 6 sides to a cube. To find the length and the width, you have to cube root the volume. Will give you the length. So if you cube root 2,744, that will tell you what the length is. We do that in our calculator. The cube root 2,744 is 14. That means the surface area of this cube is 14 times 14 times 6. The length and the width are the same because it's a cube, right? The surface area of this cube, that's the amount of area you need to paint. 14 times 14 times 6 is 1,176. The question asks you, how many cans of paint must you purchase? Well, 1 can of paint is 82. So if you have to divide that by 82 to figure out how many cans of paint you need, and you get 14.34, but you can't buy a decimal of a can, right? So you have to buy 15 total cans of paint. You can't buy 0.3 of a paint. So the answer is 15. Fantastic. Your test tomorrow will cover basically the same stuff as this quiz. So this is probably the best study guide you could have. Watch it a couple more times if you need. Study it tonight. Send me emails if you need help. Ask other math teachers in the building during Flex if you need help. Take care of yourselves. I hope to see you guys soon. Bye-bye.